Hello, in this tutorial, in this lab session, sorry. So in this lab, we will see some activities about real-world applications. So we will begin by just a revision about all this. So for computer memory and hard drive, okay, 1 byte is equal to 8 bits. 1 kilobytes, it is written in capital, the K and the B, okay? So it will be equal to 2 power 10 bytes or 1024 bytes, okay? 1 megabytes, it will be written also in capital, okay? So it will be equal to 1 to 2 power 10 kilobytes, and the kilobytes already 2 power 10, okay? Multiplied by 2 power 10 bytes, it will be equal to 2 power 20 bytes, okay? And 1 gigabytes is equal to 2 power 10 megabytes, and the 2 power 10 and the megabytes is already equal to 2 power 20, okay? So it will be 2 power 30 bytes, okay? So be careful about that. Okay, for the internet speed, the rate or download or upload, okay, the speed here, the rate is equal to the file size divided by the time, okay? So to calculate the time, we need to divide the file size by the rate, okay? So you will have 1 bit per second. It can be written, okay, abbreviation as BPS or just BS, okay? 1 kilobits per second. So the K is in capital, the B is small, okay? And it will be equal to 2 power 3 bit per second, and 1 megabits per bit per second. So it's equal to 10 power 6 bit per second. 1 gigabit per second, it will be equal to 10 power 9 bit per second, etc. Okay? Okay, do you see the screen? It is okay? It's okay? So just keep in your mind these, okay, these units, okay, with right conversion, okay? If you need to convert this from kilobytes to bytes to bits, from kilobits per second to bits per second, etc. Okay, so let's start by question number 1. So you have a smartphone that has a screen resolution of 640 multiplied by 960, okay, pixel. So this is the number of pixels. This is the resolution, okay? So how much data in bits, bytes, and megabytes is required to display an image if it uses 24 bits for each pixel? Okay, so here we have the RGB, okay? The RGB, the color, okay, the system. So the first step is to calculate the number of pixels, okay? And each pixel, and after that we will calculate the total number of bits for all these pixels, okay? And after that we will convert from bits to bytes to megabytes, okay? So let's begin by the number of pixels. So as you know, the number of pixels, is equal to the multiplication of the number of rows by the number of columns, okay? So we have this number of pixels in total. And because each pixel, look here, each pixel is represented by 24 bits, okay? So we will have 24 multiplied by the total number of pixels. This is the number of the total number of bits, okay, required, okay, to display an image, okay. After that, this quantity can be converted to bytes. So from bits to bytes, we will divide by 8, okay, because one byte, sorry, is equal to 8 bits, okay. 1 byte is equal to 8 bits, okay. And after that, from bytes to megabyte, we need to divide by 2 power 20. Why 2 power 20? Because from bytes to kilobytes, we divide by 2 power 10. And from kilobytes to megabytes, we divide by 2 power 20, okay? So this is the total, the number, okay, the data, okay, in bytes to represent an image, okay, in a smartphone screen resolution 640 multiplied by 960, okay? Is it clear? Is it clear? Are you with me? Okay. So we have Ahmed, Saadiya, Marah, Muhammad. Okay. Okay. Okay, Marah. Okay, let's move now to question number 2. So in question number 2, you have consider an image of size 100 multiplied by 240. Now this is the size of this image. Okay. How many bits, bytes, and kilobytes are required to store this image inside the computer using RGB model? Okay. So now it will be using RGB. What does it mean using RGB model? It means that each pixel requires 24 bits for each pixel, okay? So you need to understand that once they asked you to use, okay, the RGB model, you need to understand automatically that you need 24 bits for each pixel, okay? Okay, so it is we will follow the same steps. So in the first, we will calculate the number of pixels in this image. It is the number, okay, of rows multiplied by the number of columns. It equal to 24,000, okay, of pixels. For RGB model, so it means that 24 bits are used to represent each pixel. So the total number of bits needed to represent this image, it will be equal to the total number of pixels multiplied by 24. Okay, so this is the total number of bits. Okay, to convert this number from bits to bytes, we need to divide by 8. And to convert from bytes to kilobytes, we need to divide by 2 power 10. Okay, okay. And if we need to convert to megabyte now, to megabytes, okay, so we need to divide this 70.3, okay, by 2 power 10, okay. So it will be a small number, okay. Move now to the question number 3. Do you have any question till now? Are there anything that it is not clear? Clear? Any question? I need to know the number of attendants. Okay, 59. Okay, clear. Okay, move now to the question number 3. So now we have a file in bitmap format, okay, is 5 megabyte in size. So this is the size file, okay, or the file size, okay. So how long will it take to download the file from the internet if my internet connection is running at 14.1 megabit per second? Okay. So as we saw yesterday, so we need to convert. Okay, we need to use the same units. Okay, so we need to convert this megabit bytes to bits. Okay, and this megabit per seconds to bit per seconds. Okay. Okay. So in order to calculate the time taken to download, we must first convert the values to bits, okay, to the same unit, okay. Okay, so let's start by the file. The file size is 5, sorry, here is 5 megabytes, so it will be equal 5 multiplied by 2 power 10, 2 power 10, and 8 to half in bits, okay. So you can check the result. So 5 multiplied by 124 multiplied by 124 multiplied by 5. By 8. Okay. Okay, so it will be equal to this number. Okay. After that, we need to convert the internet speed from megabit per second to bit per second. So this mega, okay, we can write is to 10 power 6. So this is 10 power 6. Okay. So this is the internet speed in bit per second. Okay. Per second. Okay. Now using the formula time. Okay. Time is equal to the size divided by the speed. So the time which will be taken to download or to upload this bitmap format, okay, file, okay, this is the file size, okay, divided by the internet speed. It will be equal 3 seconds, okay. So we need 3 seconds to download this file, okay. Is it clear? Is it clear? Do you have any question? Any question? Okay, moving now to question number 4. So look at this question number 4. A common bitmap format for displaying reasonably high quality digital images is to use 24 bits for each pixel. Okay, so this is the RGB model. Okay. Okay. So how many pixels are required for this screen resolution? And how many bits of data does this require for each image? Okay. After that, you are asked to answer the question B, which is my internet connection provides an upload speed of 2.5 megabits per second. So how long will it take to upload such an image? Okay. So in the first, we will calculate the size, okay, of this image, okay, and after that we will convert this size, okay, or we will convert to the same units and use the time formula, okay, or the speed formula, okay. So let's start. How many pixels are required here? So there are the number of the rows multiplied by the number of the columns, okay. This is the total number of pixels. And because each pixel uses 24 bits, so the total number of bits required for this, okay, for this resolution, okay, which will be equal to this amount. So this is the amount, or this is the file size. Okay, now the upload size speed is 2.5, sorry, here, 2.5 megabit per second. So we convert this value to bits. It will be equal to 2.5 multiplied by 10 power 6, the mega 10 power 6. So this is bits per second, okay. And using this formula, time is equal to the size divided by the speed. So this is the size and this is the speed, okay? And this is the time required, okay? It is 7.55 seconds, okay? So less than 8 seconds, okay? Seconds, okay? Is it okay? Are you with me? Clear? Okay. Okay. So now move to the question number 5. So now consider a 1 hour film. Okay, so this is the duration of the film, 1 hour film, to be displayed on a computer at 24 frames per second. Okay, so we have 24 frames per second. Sorry. So each frame, this is each frame is 240 multiplied by 100 pixels, and a 24-bit RGB color encoding is being used. Okay, so how many required to represent the whole film? Okay, so here you are asked to calculate the size, okay, of this film, okay, with these specifications. Okay, so in the first we need to write or to calculate the number of pixels, the number of bits needed to represent this. Okay, one frame. Okay, one frame is like one image. Okay, so the number of pixels is one frame is equal to 24,000 of pixels. The number of bits now needed to represent one frame is the total number of pixels multiplied by 24. Okay, because here we use the RGB color encoding. Okay, so this is the number of bits here. This is bits. Okay, and the number of bytes now we can, okay, divide this number of bits by 8 to have the number of bytes. Okay, so now the number of seconds in 1 hour is equal to 3,600 seconds. So the number of frames in 1 hour will be, okay, the number of frame is the time multiplied by the speed. Okay, so here the speed frame per second. Okay, so number of frame divided by the number of second. So to calculate the number of frame, we need to multiply the rate by the time. Okay, so this is this one. So we will have this number of frames, and because each frame, this is the size of each frame. Okay, so the whole film will be this size in bytes. Okay, the number of frames multiplied by the size of bytes needed to represent one frame. Okay, so this is in bytes, and to calculate this amount in gigabytes, we need to divide this one by 2 power 30. Okay, 2 power 30 divided this one by 2 power 30. So you will have 6.07 bytes. Okay, is it okay? You have any question? Clear? Is it clear? Clear? Any question? You don't have any question? Move now to the question number 6 now. So now consider a 2 hours film to be displayed on a computer at 30 frames per second. Okay. Each frame, this is the size of each frame, and each pixel uses 24 RGB color. Okay, so how many gigabytes will be required to represent the whole frame? Okay, we will apply the same steps. Okay, so in the first we will calculate the number of pixels in one frame. Okay, the number of bytes in one frame, the number of frames, okay, by the time multiplied by the rate, okay, and after that we will calculate, okay, we will convert this amount from bytes to gigabytes. Okay, so see, this is the number of pixels. Okay, so here we have this, we have 24,000 pixels. Okay, so the number of bytes now in one frame, it will be equal the number of pixels multiplied by 3. Okay, can you explain me how we can get here 3? Can you explain to me what is the meaning here of 3? Good, Sadia, good. So it is 24 bits divided by 8, the size of bytes. This is why here we have 72 good first 72,000 of bytes here. So here we have bytes. Okay. Okay, now the number of frames in the film is the duration of the film in seconds. So we have 2 hours. 2 multiplied by 60 minutes multiplied by 60 seconds, okay, in each minute, multiplied by the rate, okay, by the rate, okay, of frame per second. Okay, so this is the number of frames here. Here the number of frames. Sorry. And the size of the whole film will be the number of frames multiplied the size of each frame, okay, in bytes. So this one is in bytes, okay. We can divide this amount by 2 power 30 to have this amount in gigabytes, okay. Is it clear? Okay, is it clear? Do you have any question? No questions? Okay, thank you for your attention. And this is the end of this lab session, okay? So this is the end of this lab. If you have any question, you are welcome. It is different, okay? To convert from megabytes to bytes, okay? It is with the computer, okay? With the computer storage and computer, okay? This is for the computer's memory and hard drive, okay? When we talk about data to store in the computer, we talk about bits, okay? 0 and 1s, okay? So we are in the binary system, okay? But when we talk about rates, okay? So it is with the decimal system, okay? So we will use 10 power, 1, 2, 3, 4, etc. Okay? Muhammad, just you redo this activities. It is enough, okay? It is enough for you. Just you need to understand the steps and to follow the right steps, okay? Okay, thank you very much for your attendance.